Suppose we have the following data for zero coupon bond. So this means that there is a contract that pays $100 in the particular maturity. So at the maturity 0.5, the price is 99.1338, which means that the value of a contract that pays $100 in 6 months later, which is 1 year, is 99.1338. So we can apply the formula we just learned. So the value of a contract is 99.1338 should be equal to $100 the contract pays at the maturity, and e to the power of minus r 0.5. Right? And this r is here 1.74. Right? So in order to calculate r, what we have to do is, right, we can divide each side by 100. So 99.1338 divided by 100 and take log, right? And then divided by minus 0.5 part of 1 should be equal to r. And let's check whether this r is equal to 1.74%. Let's move to Excel. So we can apply the previous one. So this is the value of the contract, and at the end of the 1 year, we'll receive $100, which is called the face value. This one, and then we put log, and then we can divide this one by 1 over division, so 1 over, so it is 0.5, so this one 0.5, this one, and then we put minus. So it is not, it is almost 1.74%, so we can make it percent. So we have 1.7%. We apply this formula, and we have 1.74%. And for others, I can simply drag down. So we have this one, this part, right? So when the price of the contract that pays $100 in 0.5 years is 99.1338, the yield or spot interest rate over the period is 1.74%. Likewise, when the value of a contract that pays $100 in 1 year is $97.8925, then the spot rate is 2.13%. And then this one, when the price of the contract is $96.1531, then the yield is 2.62%. So this is yield. And the relationship between this maturity and yield is called term structure of interest rate. And the relation with the curve, that the relationship between maturity and yield is called yield curve. Next, let's think of the forward rate. What is forward rate? Here, forward rate means that forward rate is the interest rate between two future dates. And we determine the interest rate, that forward rate today. Here, the first one, it is the interest rate because it is maturity 0.5, and we want to determine interest rate from today to 0.5, so it should be same to today's spot rate, 1.74%. But then next one, we have to think of the more. Next one is, it is interest rate that we have to determine today, interest rate between 6 months later, 0.5 years, 1 year later. And how we can determine this forward rate? Well, we have a hint, we have two rates. Interest rate between today to 6 months is 1.74%. And interest rate between today to 1 year is 2.13%. Using these two ones, we can calculate forward rate. Let's think of a timeline again. It is time 0, 0.5, and 1 year. And then suppose there is $100 over here. Then the value of this contract at this point is, as we learned, this one. Let's say this one. One is, the value of this contract is $100 multiplied by e to the power of, is 1 year, so we have to use 2.13% and 1 year. Alternatively, the value of this contract is, we can go first this and this. And this is the forward rate we are interested in, and this is spot rate. So 2 and then 3 is $100 to the e to the power of some forward rate between the period 1 minus 0.5, so 0.5, and then multiply. Now we think of as third root. We again apply the formula e to the power of minus 1.74%, 0.5. Well, this 1 and 2, 3, both of them generate the value of exactly same contract. Therefore, this should be same. Therefore, we should have 2.13% 1 year should be equal to forward rate 0.5 plus 1.74%, 0.5. Right? And from this one, actually, we have very interesting pattern. This long-term rate, 1 year rate, 0.2%, 2.13% is basically weighted average of these two rates. So rate at time 1, this particular rate, this rate is weighted average of this rate. And the weight is given by the length of the two time. Right? So this 2.3%, 13% is basically, we divide each side is long years. This is F 1 over 0.5 plus 1.74%, 1, right? So this long yield, long spot rate, this 1 is weighted average of forward rate and then short-term rate. To make it more general, let's say there is a timeline. This is 0, and this is T1, and this is T. So the distance is T2. Then rate, long run rate should be equal to R1 T1. R1 is the rate between 0 and T1, and the forward rate F multiplied by T2. So this R, long rate, is weighted average of R1 T1 divided by T plus F T2 divided by T. So R is weighted average, weight given by time. If we use terminology of geometry, then this long rate R is basically internal division of a segment. Internal division with the distance between the two periods or 2 points. Or we can express F, then F is basically T2 and RT minus R1 T1, which is because T2 is simply T minus T1, therefore it is RT minus R1 T1. When we learned high school that this is a formula. This is the formula for external division of the segment. External division of the segment. So therefore, we have a very interesting result that long-term yield or long-term spot rate is internal division of forward rate and then short rate. And forward rate is basically external division between long-term rate and short-term rate. We can use this one and calculate this forward rate. So again, we are in Excel. So to recover this one and this one. First one, at the initial period, forward rate is same to short-term rate. And from the second one, we can apply the formula that forward rate is the external division of a segment. Therefore, we can multiply this long rate and this one minus this one multiplied by this one and divided by this one minus this one. So this is about 2.52%. Yeah, 2.52%. We can replicate this one, copy and paste. So we have 3.59%. So we could calculate forward rate.